Welcome back, everybody, to the Python tutorial seminar series. Today, Drew Camron and Max Grover will be covering pandas. This session will be recorded and published and will be about an hour long. Before we begin, just to review our code of conduct, by joining the Zoom call and participating in this tutorial seminar series, you've agreed to adopt these core values: engage in respectful communication only, and be respectful of our hosts and of the fellow participants. Any disrespectful remarks will have you removed from the call. The seminar is only an hour long, so we will try our best. The other co-hosts will do our best to provide some help in the chat, but ultimately, if you're stuck and can't move forward, just try to sit back and relax, and we'll get you back up to speed before the next session. And some learning resources for today. As always, Stack Overflow is a great tool when you have questions. The Pandas documentation has almost everything you need to know about pandas. And for today's content, everything is on a GitHub, which I will post in the chat now. Okay, and now I will send it off to Drew and Max.
Thanks, Julia. I'll go ahead and share my screen. Alrighty, so Julia posted the link in there. If you haven't done this already, we'll go ahead and clone this repository onto your computer. So you just open up a terminal here, copy and paste that link. So we'll do git clone. And some of you might have already done this already. And if you have, just go ahead and run git pull. So now we can go ahead and move into this NCAR Pandas tutorial directory. And at this point, we see that there's an environment file there. So we'll do conda env create -f the environment.yaml. So we'll go ahead and create that kind of environment. So again, if you've already done this, please make sure to go ahead and run git pull. That's git space pull, and that'll load the most recent changes into that repository. And if you need any additional help, please be sure to enter that into the chat, and people will be able to help you out with that. So the kind of the format we'll do today. So Drew and I will kind of be switching off. So I'll go ahead and help you all sort of get set up here and fire up this Jupyter notebook or this Jupyter lab that we'll be using. And then I'll hand it off to Drew to sort of do first section, and then we'll wrap up with the second section, and then we'll take questions after that. So just waiting for it to solve this environment. The environment we're using today is fairly minimalistic. So we have just JupyterLab, Pandas, as well as Matplotlib in terms of the libraries that libraries and packages we'll be using today. Let's go ahead and download all these different packages. All right, so now we can go ahead and activate the environment. So conda activate NCAR Pandas tutorial. You'll see that it activates it here. So you can see that NCAR Pandas tutorial. And at this point, we'll go ahead and run Jupyter Lab, which, as long as you have that browser pulled up, will pull up that interactive environment, which we'll be using for teaching today. So just go ahead and give that a second to load. Starts up our notebook. And we can see this here. So you'll see a variety of content in here, such as this ENSO data CSV, which is our data file, the content environment. Then you'll have two notebooks here. So the Pandas full notebook is a fully executed notebook. So if you want to just follow along with that, you can. Otherwise, this Pandas seminar is one where it's not executed. So if you want to do that, if you want to use that instead, I'll go ahead and do that. So at this point, I'll go ahead and stop the share and hand it off to Drew, and Drew will get you started with an intro to Pandas.
Yeah, thanks, Max. Let me get this shared and make sure everybody can see everything. All right. If at any point the text is too small or there's any struggle seeing or following along, just flag me down. But if we're good to get started, reiterating what Max just introduced, we have two notebooks here. We kind of set up this repository that was linked in chat to be able to exist even after our brief seminar today. So you always have a reference to go back to if you want to play around with this in the future, set up your environment again. We have two notebooks today. If you've downloaded the full repo, this full notebook.ipynb has sort of our fully complete self-sustaining notebook. You can browse the preview of this even on the GitHub repo if you aren't able to set up Python or clone this repository today, if you just want to sort of read along with us. But if you're going to be coding along, we're going to be working in this Pandas seminar notebook today. So I'm going to start there. If you're new to Jupyter Lab, to make some room on the screen, I can collapse some of the extra elements around the edge of my screen to make room for just our notebook. If you're using Jupyter Notebook instead, then this probably looks familiar and closer to where you're at. So today I'm going to introduce, in our brief 45-ish minutes, introduce Pandas. This is an introductory seminar. So basically what we want to cover today are what are the key pieces and parts of Pandas that I will see, that I'll be seeing and I'll be using. Notably the Pandas data frame and Pandas series. These are important data structures that Pandas provides to you. I'll move into how you interact with these in terms of indexing, subsetting, selecting, sort of exploring and slicing through your data. And then I'll pass off to Max to let him really demonstrate some of the extra functionality that Pandas gives you if you choose to use it in your workflow. So we'll start today with just importing Pandas. It's the only thing we're going to need today. Pandas, you may have encountered its name before if you haven't already used it. Pandas as a whole is heavily built on top of or adjacent to NumPy. And so if you have familiarity with sort of the basics of Python on its own and some familiarity with NumPy, then you'll see a lot of similarities, a lot of familiarity, and you'll get a lot of the benefits that NumPy gives you, but then Pandas will give us sort of even more functionality on top of that. So to start with that, we'll introduce one new piece that Pandas gives you, which is the Pandas data frame. This is an object in Python that heavily draws inspiration from tables, spreadsheets, or maybe the data frame from R, if you're familiar with some of the structures in R. So a Pandas data frame in Python is a two-dimensional collection of data. It's primarily centered around columns of information. Each of these columns has its own label, and that's important. We'll keep coming back to this. The labels of information in Pandas are powerful and are helpful. So each column has its own label. The data and information within each of these columns can vary wildly, can be just about anything you may have run into or have yet to run into in Python. So they can be strings, characters, numbers, NumPy arrays. It can be just about any kind of information that you'd want to store in a sort of table. Extending from the sort of columnar organization of our data, our data frame will also have an index column, sort of the 0th column This column gives us information about our rows. This tells us how our data is organized, and this also comes with its own labels that allow us to access and explore our data in a variety of ways. We have, as Max mentioned, sort of a lot of guiding text sprinkled throughout the notebook. We don't expect people to read along today, but it's there for reference after the fact, or if you need some time to catch up during the seminar today, but it's there for you. So the first thing we're going to do is instead of sort of manufacturing our own data today, we're just going to start by reading in some data. One of the most common use cases you might run into with Pandas is reading in tabular data. So often CSV files, I think even Excel spreadsheets, you can, or fixed width text files, basically any sort of table or tabular information you can read in with Pandas. So to even start looking at a data frame, we're going to read in this provided nsodata.csv file that's in the repository that you downloaded. And then we can just print df to take a look at the data frame we just read in. So I can actually, and if you're using Jupyter Lab, you can do the same thing. I can actually show you what this file looks like before reading it into Python. It is this tabular structure with a date time column and then Nino 1-2, Nino 1-2 anomaly, and so on columns. What these are physically may be relevant to you, may not be. We aren't going to be diving into that today. We just thought this was a good example of something that we could easily read in with Pandas and demonstrate. But for people curious, these are the monthly area average sea surface temperatures in each of these Nino index regions, the Nino 1+2, 3, 4, and 3.4 regions. So if we just print our data frame, if you're using Jupyter Lab, you'll, at least newer versions, you'll get this sort of nifty HTML view of your data frame of a table. If you are not using newer versions of Jupyter or Jupyter Lab, or if you're in Python, just sort of the traditional Python interpreter, you might see something that looks a bit more like this. It's still well organized, but a little less HTML fancy. So we have our fancy representation of our table here. We have, per our schematic above, a indexing column on our far left that tells us how our rows are organized. So far, that doesn't look particularly helpful, but we'll take a further look at that in a second. And then we have across the top our indexing row of column information. So the names of each of our columns of data. In any data frame or later when we get to the Pandas series, just a moment, you can access the indexing information of your data with the .index property. And so in this case, this is telling us that our first column in our table, this 0, 1, 2, 3, 4, down to 471, is just that. It's just a range of numbers from 0 to 472, indicating that we have data ordered from 0 to 471. That's not particularly helpful for us in understanding how our data are organized, or once we hand it off to Max, manipulating our data. So if you were using this in your workflow and you wanted to assign some sort of index that you've created elsewhere, maybe as a NumPy array or as a list of labels, however you might be organizing it, you can assign this index to be whatever you want it to be, whatever you create. But Pandas is, unsurprisingly, kind of smart. So if we go back up to our read CSV, get rid of a couple things here, earlier for reading in our data, we're going to do two things. We're first going to tell it which column from our file actually contains relevant indexing information for our data. So from looking at this table above, the one column that we think is most helpful in organizing the rest of the table would be our date time column. These are monthly averages. It makes sense to pull out what months they were noted. So let's tell it that we want the index column to be our 0th column, or the very first column in the data file. Let's take a look at that. I'm going to run this cell, print out the data frame again. And you'll see now our indexing column is this date time column. It's got dates listed in it. To look ahead and cheat a little bit though, I want to look at that. Don't worry about the specifics too much here. Just note that all that Pandas sees this is some generic object. Pandas, and some of the most powerful parts of Pandas, are uniquely tied to time series and time indexing functionality. And so if you tell Pandas to try and parse the dates that it finds within this index of your file, nothing appears to have changed. But now if I take another look at the index, we have this new date time index with this proper datetime 64 object that it sees. This unlocks a lot of functionality that we may find useful later down the line. It's not a requirement, but just something useful that Pandas can do just when reading in your file, if it's able to parse the dates. To wrap up what a data frame looks like, you can, just the same way we were using df.index to see our sort of column that describes each row of our data frame, we can, of course, just see the columns within our data frame. You'll notice that date time is not among these. That's not considered a sort of column of data. That is our index, and it's a totally separate thing as far as Pandas is concerned. So the columns of our data within this data frame are Nino 1-2, 1-2 anomaly, so on and so forth. So we'll pause there for just a second for me to rehydrate. And we'll move into the Pandas series. This is probably the second most common piece of Pandas that you'll find yourself interacting with, at least as often as the data frame, if not more. And you might be interacting with it even if you don't realize it. So a Pandas series is basically any one of those columns from our data frame. Even on their own, even just as a column, they importantly retain the indexing information from our data frame. So per this schematic here, we have this sort of dark gray on the left, light gray on the right. This is indicating that when we pull out any of our columns from our data frame, it keeps that date time index we created earlier. And so even for any one of our columns, we can keep tabs on how they're organized, and we can access them with those indexing labels. The Panda series is always one-dimensional. It's always like a list or a NumPy array. And it's built on top of NumPy. And Pandas series is fast and has a lot of extra functionality that we'll start to touch on later. To interact or to actually take one of these series out of our data frame, recall this is what our data frame looks like. Let's come down and we can use the Python dictionary notation with the sort of brackets and quotes with the name of our column to pull out that series. This has a little bit less fancy of a representation in Jupyter Lab, but still you'll see basically a list of your data. To the left is this sort of dark gray indexing column per this schematic up here. These are the labels by which you can access your data, which we'll get to in just a moment. And then to the right are the data themselves. Down here, we have the name of our series, how long it is, and what data types we have within it. And again, as I touched on with the data frame earlier, you can cram just about any kind of data type into Pandas series. To save some time for our poor fingers later, we will often shorten this to the sort of clever pandas dot notation. If you've used Xarray, you may have seen this, or you may see this as well. So we can just use dot column name to get to our, to pull out a column from our data frame. So these are Pandas series. We're going to stop there and for introducing what a Pandas series is. And now we're going to move into how we can actually dive into exploring Pandas series and Pandas data frames, what that looks like and what sort of capabilities we have to really sort of slice and dice and look at our data. You'll find that some of this syntax, some of this context is shared between the Pandas data frame and the Panda series. You'll find that some of it differs, and we'll try and touch on that where we're able. An important concept I introduced at the start is that one of the key capabilities that Pandas gives to you on top of NumPy is the labeling, is being able to access your information with the name of the columns or the name of the rows, etc. So in general, for both the data frame and the Panda series, we can access our data by its labels, no matter how it's organized. And to demonstrate that, we're going to work backwards a little bit here from how I introduce things. We're going to start with the Panda series. So here I'm going to pull out, we can see EF Nino 34 here with the dictionary notation that I introduced above. This means I'm pulling out the Nino 34 column from my data frame, and I'm assigning it to its own variable. We take a look at it. It's the same series we were looking at above. Just now, we can stop typing. We can stop referencing our data frame every time. We just want to take a look at this series. Series can be indexed, selected, and subset similar to NumPy arrays. So with the sort of bracket integer notation where you pick the sort of nth value in your series. So this will, similar to NumPy and remembering your Python indexing rules, this will pick out the 0, 1, 2, 3. So the fourth entry in our series, and we have ourselves a value. So this is the 28.02. This is degrees Celsius, by the way, value from our series. Series can also be indexed by label. So if I know the label, regardless of where it is in my series, for the data that I want, in this case, I know I want the April 1st, 1982 average sea surface temperature from our series. Using the same dictionary notation I used to pick out a column earlier, I can pull out a value from our series. These, both of these demonstrations and functionality can be extended. They can be extended in ways you might be already familiar with if you're comfortable with NumPy. So you can use the sort of NumPy number slicing notation, like I've shown here, 0:12, indicating I want every value from the 0th entry to the 12th entry. Let's run that. And sure enough, I have our very first entry from our series down to the 12th entry. You can also do this same slicing with strings indicating your labels. Pandas will go through and find every value between your first string and your second string. So here, for my Nino 34 series, I have said that I want every value indexed at 1982 January 1 all the way to 1982 December 1. And sure enough, I get the same thing. I printed out with my NumPy notation above. If you've used Xarray or been exposed to their documentation or just have found yourself comfortable with manually constructing these Python slices, you can do that here too if you like. Works the same. Importantly in Pandas, a little note, unlike the rest of how you may have interacted with Python or NumPy so far, when you slice by labels, as we've done with these previous two cells, you will include the last value. So if you say 1982 January to 1982 December, you will get December. Whereas in other places in Python, you may have encountered that you'll get the value before that. We're going to touch on this sort of may just be more of a convenience for you. This is not necessarily a requirement. We're going to touch on some sort of more Pandas preferred ways to access your information in a series and data frame. Using these, which I'm about to introduce, the Pandas loc and iloc, or locate and locate by number, may help you avoid some warnings in Pandas that you've run into before or will run into that have to do with memory reference. It can slow things down when we introduced sort of chaining, picking data out of data frames later. But we'll talk about that when we move on to the data frame. Point being, we can use pandas .iloc property here to do the same thing we did with our sort of NumPy notation. This is locating by the third value. Similarly, we can slice. And just the same, we can use .loc without the I for label-based location and slicing. This may, if you're doing a lot of heavy lifting in pandas, this may be faster than the sort of bracket notation we were discussing above. But it may not be necessary for just quick exploration. So let's move on to data frames and wrap up this section so that Max can show you some math and plots. Indexing data frames is in many ways very similar to what I just showed for our series. However, there's a few key differences. Notably, if I go back to my data frame, recall it's just called df, excuse me. This is what it looks like. You might think that if I pass it the label for January 1st, it'll just give me that whole row. It won't, sorry, didn't mean to mislead you. That can be confusing to some or frustrating up front. But and similarly, using this, just passing in a single number isn't going to work on our full data frame at first glance. But let's recall what I cheated and showed you earlier, and that by default, this sort of bracket quote notation in a data frame will let you pull out columns. So because each of these columns is its own Panda series, we can access those with their label, the same as we did before. We've already done that earlier, but reminding you, this is how we can do that. And with the, again, with the sort of pandas notation. Now, if you don't want to do what we did before, where you pull out a column, type it out, that's what I'm going to work with. Let's assign it to something new, like 3-4 or series 3-4. If I don't want to do that, and I just want to pick out one value for my entire data frame to look at, I can do this sort of nested notation, kind of like nested lists in Python. I can pull out our series, our df Nino 3-4, and then I can go ahead and pass it the label or value index that I want to take a look at. It's basically the same as first selecting our column and then picking the row. Pandas isn't always a fan of this, and this is where you might start to run into some warnings and heavy lifting with pandas, but you can do this, it's fine. If you want to then tie it back to what I briefly introduced and sort of have a pandas preferred way that gives you a lot more flexibility up front, here's where we can make .loc and .iloc do some work for us. So we used this on a series before. Now we're going to use it on our data frame. With .loc here, I can specify, for one, I can just specify a row. It successfully found my April 1982 row in my data frame, and it pulled out the value from each of my columns in my data frame for me. You can also go ahead and tell it which row first and which column you want to pull out of a data frame to go straight to that value. This is generally faster than the sort of bracketed double brackets notation I was showing earlier, and a little bit safer to use. And like I said, can sort of take you straight to the value you're looking for. Within .loc and within specifying which rows you want to pull out and which columns you want to pull out, you can slice. You can sort of get more clever with it. In this case, I want to slice through rows. I'm not going to specify any columns, just give me all the columns. And I'm going to slice through from rows 1982 January to 1982 December. And sure enough, we get a smaller data frame that's a subset of our first data frame containing just the rows 1982 January to December for each of our columns. As above, you can use iLoc either on your own or programmatically maybe to pull out individual rows in your data by index or row and column by index. And you can NumPy style slice with iLoc, just the same. As well as you can do this for both rows and columns. So here I've got, it might look a little organized. It might be organized a little funky, but I've got a dot loc. My first argument is the rows I want to collect. So I'm telling it I want to slice with this colon, 1982 January to 1982 December. And then I'm going to give it a list, if I know the names of my columns, a list of all the columns I want these values for. In this case, I don't want the whole data frame. I just want values for Nino 1, 2, 3, 4, and 3, 4. So if I do that, I get an even smaller subset of my original data frame. To wrap up this section, we have there are a few links nested throughout this notebook, including buried, if I scroll back up, don't mean to bounce around. If I scroll all the way back up, some of the headers have links to the Pandas documentation for you. You might find this helpful. But at the end of our indexing section, we have some suggestions for places you can continue to see some of the rules and some of the limits to Pandas indexing. Max is going to talk a bit more about some advanced subsetting in a moment. But also there's many sort of shortcuts that you would have access to quickly get information about a data frame. And that's where Max is going to start in a moment, including just quickly seeing the head or tail, the beginning or end of your data frame. And with that, I'm going to hand it off to Max to talk about plots and numbers.
Thanks, Drew. Go ahead and share my screen. Is that a good size? Do we need more zoomed in? I'll go a little. All right, so at this point, we're gonna do some data exploration with pandas. And this is really kind of the point where we can sort of see just the power of using pandas. So what's neat about pandas is without even importing matplotlib, you can actually plot your data. So this is really helpful for exploratory analysis. So in this case, we'll take our data frame, use the Nino 3.4 series, and then call .plot. And then this semicolon after here is just to remove some annoying text. So our result is this time series. So we can see along the x-axis, we have our date time with the years, and then along the y-axis is the temperature in degrees Celsius of that region, which is the Nino 3.4 index. This can be sort of a great kind of first look at your data and just kind of wrapping your head around of what's in these different data sets. If we just call this on the entire data frame, I would actually return the time series of all those variables. You could see the Nino indices themselves up around the 20 to 30 C range. And the anomalies are down here. So again, this can be sort of a good entry point in terms of exploring your data and without even requiring importing matplotlib. So what if you wanted more of a sort of quantitative perspective? Pandas has some great handy functionality for that too. So we can pull out some just basic statistics here. So if you call .describe on your data frame, we can get some statistics. So looking at this, we can see count, which is the total number of rows in your data set. And so you can see all those values match, which should be the case. You see the mean, so we have our average, STD stands for standard deviation. And then we have the min, max, and then the different percentiles. We have the 25th percentile, 50th percentile, and 75th percentile. So again, this can be a great sort of just entry point in doing any sort of exploratory analysis you might be working on. Now, if you just wanted a specific statistic here, so let's say you just wanted to look at the mean, you can use just your data frame .mean, and what that will return is this series where the rows are now each individual column. So you can see the Nino 1, 2, Nino 3, and so on. And then the mean values. So just double checking here. So the Nino 1, 2, average value 23.2, 23.2. So again, that could be without calling in NumPy or some of these other packages. You can do this natively within Pandas, which is super helpful. And then if you're interested in just like a single column or just a single series mean, it uses that similar functionality where you use your data frame dot whatever series you're working with dot mean, and that will give you just that single value. So Pandas offers some of these statistical tools, which again can be pretty helpful. And just a warning, I'll kind of be, yeah.
There was a question in here that I thought I'd direct you right now. Seth McGinnis asked, if you have a data frame with mixed types across the columns, what does dot mean do on the whole data frame?
Yeah, that's a good question. So I believe it will just skip. So for example, if you give a NaN value in there, it will just sort of skip that value, or if it has trouble reading that value, it'll just skip it. So that's something to be careful of in terms of having sort of mixed values in a single series. But yeah, so I hope that helps. Yeah, so that's something just to be sort of aware of, is just sort of what to do with either missing values or mixed type values. Obviously, in the tutorial today, we won't necessarily get to all that, but yeah, we can link you to some additional resources for that, or even a later tutorial sort of going over how to deal with missing values or mixed data types. So it's a good question. So some other neat plotting functionality. So obviously when we just call .plot, it defaults to that just a line chart. So if we're interested in other types of plots, it has the ability to do that. So here we're using .hist, which will return a histogram. So we're subsetting for just these two columns or series, so the Nino 1, 2 and the Nino 3, 4. And you can see it generates this histogram here where we can see differences within the distributions here. And so there's other plots you can use too. So for example, here we're calling plot.box. And the way this format works is you have whatever your data frame is or whatever series you have, you call .plot and then the specific kind of plot you would like. So here we're looking at a box plot where you can, again, see differences within the distribution. And if you're interested in other plots, so I'll go ahead and click here. So the Pandas documentation includes a list of the different kinds of plots you can create. So again, the default is this line plot. We used hist as well as the box plot. But feel free to explore some of these other plots. And some of them require both an X and Y variable, so cognizant of that. But again, there's some really great tools in terms of just one-liners that you'd be able to create some of these visualizations. So as Drew mentioned earlier, there's some other ways to sort of subset, especially using some of the information about the data itself. So let's say you wanted to just look at the month of January. So you can use this date time column, which in this case is the index .month, and what using df.index.month gives us is this set of indices with the month. So if we go back to here, you can see obviously it starts with month January 1 or January 1, 2, and so on. And so in terms of looking at and subsetting for just a single month, we can use this notation here where we're taking our data frame and we're looking to where this index equals. So this is saying where it's equal to 1. So what this returns is a data frame with all the month of January. So we could obviously change this to other months if we wanted to. You can also use dot year here. So let's say you just want to look at the like 1985, or for example. So this provides some pretty easy indexing in terms of using that date time column. And then you could even assign this month to its own series or column. So let's take a look at our data frame now. You'll see that we have this month column where it stores an information about the month. So this is just an integer that lines up with the month. So now that we have this month column, we can use group by, which some of you might be familiar with group by. And so what group by enables you to do is, again, sort of subset and grab all the specific months and then apply operations on those. So if we just include group by.month, it gives you this group by object. And so really what we want would be the mean of this group by. And so this group by month returns this data frame where now our index is each month, so January through December. And this is taking the average. So this is taking all the months of January across this entire time period. It takes the average across there. So if you wanted to plot that out, you can go ahead and call .plot. So you can see what the average Nino 1, 2, the average Nino 3, Nino 4, and so on values are for the month of January through the month of December. So this could be helpful for whatever analysis you're looking at. So you can also use conditional indexing such that you search for rows that meet a certain criteria. So let's say you wanted to look for where this Nino 3-4 anomaly is above 2. So you set up your query like this. So you have your data frame set up here. So this is saying looking for where this Nino 3-4 anomaly is greater than 2. And this will return a data frame that meets this criteria. So this will return the entire row. But if you look at this Nino 3-4 anomaly column, you'll see that all these values exceed 2. So again, this could be helpful if you're looking at some of the more extreme values, or you want to sort, for example, temperature or whatever variable you're interested in. You can also sort values. So use the sort values, or somebody else brought up earlier, where if your indices aren't necessarily sorted, you can actually use .sort index, and that will sort your indices for you. Let's say we wanted to sort our values based on this Nino 3-4 anomaly. So if we call .sort values and then input which series you want to use to sort, you'll see this Nino 3-4 anomaly. It sorts it from lowest value to highest value, and this is the default within Pandas. Now, if you wanted to sort, if you wanted to have the highest values at the beginning, you would basically replace just passing nothing into the argument to the ascending is equal to false. What that will give you is this Pandas data frame with the Nino 3-4 index sorted by the highest values at the top. And so this can be, again, handy if you're looking at, all right, well, where is the Nino 3, what month had the 3-4 anomaly, and what were the other indices during that month? That's what this will give you, and you can quickly look to see, okay, well, November of 2015 had one of the highest Nino 3-4 anomalies, or the highest Nino 3-4 anomaly within this data set. So you can also do resampling within Pandas. So let's go back to this Nino 3-4 plot. So obviously you can see pretty noisy data here. And if you wanted to resample, say, on a yearly scale, you could use the df.nino34 resample. And here we do yearly, so we use 1y, which stands for that. And we can go ahead and link to this documentation to see the rest of the syntax is there. Called .mean.plot. And what that gives us is this resampled data set. And so if you wanted to do on like a 5-year scale, you could also do that. So again, this is sort of grouping it into years of 5 and taking the average across there. So if you're working with especially really high temporal resolution data and you want to get, say, 5-minute averages or 10-minute or hourly or whatever sort of temporal frequency you want to change to, this the resample can be a really helpful function within Pandas. Now, sort of the last thing I want to touch on is applying operations to a data frame. So I'm sure a lot of, especially scientists, will sort of be doing different conversions and different calculations in their data. So in this case, we're going to use an example function of converting from degrees Celsius to Kelvin, since the Nino index is in degrees Celsius. So here we set up this function. So all we're doing is taking whatever you input argument, whatever this input argument is, we're just adding 273.15. So this function set up. So if we just test it on 0 Celsius, we get what we should get, which is 273.15. So let's say we wanted to apply this to this Nino 3.4. So you can see here, these temperatures are in degrees Celsius. And so just sort of understanding what's going on here, this data type here, this Nino 3.4 series is a Panda series. So you can see it has the values here, the date time, which is the index, see the name of the series. But if we call dot values, what that returns is this numpy array. And so since the underlying, you can see here, it's that numpy array. So since we're working with numpy arrays under the hood, this allows us to do these calculations. So if we apply this function to our data set, you can see here it's returned the temperature in Kelvin. And what we fed it was this Nino 3.4, this series, this Panda series, and it returns this Panda series. Whereas if we call dot values, we input that numpy array, and it returns this numpy array. This is really, if you're interested more in this, obviously we're sort of limited on time, but this really sort of shows the power of just being able to apply some of these functions on these different Pandas data frames. And so now that we have this temperature conversion, we can go ahead and assign that to a new series within our data frame. So now let's take a look at our data frame again. So within our data frame now, we added that month column. We also added that Nino 3.4 in Kelvin. And so if you wanted to save this for later, if you wanted to share it with somebody else, Pandas has some functionality to be able to output your data. So if you use this Pandas data frame .2CSV, you feed it the file name. So in this case, we're putting into a CSV. So we call Nino analyzed output .csv. And we'll go ahead and take a look at our local file system and give it a second to load. And so what that did was it saved it into a CSV. So we can double check that everything's there. So you can see this output CSV. So we see the date, time, all of our indices and anomalies. But then at the end, we see those two newly created columns. So again, this can be really helpful if you're working on calculations or different analyses and you want to be able to output to a CSV. Continue to use Python. If you want to use different language to, or different program to analyze it, you can. And then just to double check that we can read back in this CSV. So again, we use similar syntax what we did earlier. So the index column, so we use that first index column. We want to parse the dates, and that returns back that data frame that we expected with the newly calculated values. So I know that this last section cruised by pretty quick. I noticed that the chat kind of blew up a little bit. And so, yeah, at this point, we'll kind of open up to questions and hope to answer some of those. We hope that this gave you at least a good intro to Pandas. There's a lot of really great resources in terms of learning more about functionality within Pandas and how you can use it within your daily workflows. And obviously, we've sort of just scratched the surface, but we look forward to answering some of your questions. And thanks so much for checking out this tutorial. So yeah, so we'll go ahead and answer any questions you might have. Yeah.
Yeah, feel free to type questions in the chat and we can repeat them and answer for people, or regardless, otherwise, thanks for coming to attend.
There are a couple questions in the chat. Have they been answered?
So I know that Steve just put a question. Is there any good reason to use pandas instead of Xarray? So pandas is really good with tabular data, whereas Xarray is really good with sort of more, I guess, I'm trying to think of the right word here. It's better with, yeah, the data structure is better for working with like gridded data. I guess is probably, yeah, higher dimensional data. That's a good way to put it.
Also,
in fact, I'd say if you think about it, Xarray is sort of pandas for multidimensional data.
Right. And actually within Xarray, they actually use pandas for a lot of the indexing. So that's why some of the data structures here look somewhat similar. And in some ways they're actually, I mean, they're using pandas for some of the indexing within Xarray. So,
and to directly address your question, you can use Xarray for purely one-dimensional data or collections of one-dimensional data, the same as pandas. Pandas, other than having sort of existed before and laid the groundwork for Xarray, can be incredibly fast. So for something in Python, at least. So if you say find yourself ingesting, millions of data points from a constantly reporting weather station or something like that, something that just saying one point in time for a long time, pandas can handle that probably a lot better than Xarray can. And so if you're working with a lot of one-dimensional data, a lot of columns of data, you might find yourself wanting to use pandas.
Yeah, so like good examples. So yeah, like weather stations or like buoy data. When you're working with sort of specific stations or specific sort of point data, it can be helpful to use pandas.
So there's a question, can pandas be thought of as a structure along the index dimension?
I think yes, with a lot more, like pandas through some very low level programming. So we introduced, say, the date time index here today. Pandas tries to give access to something that's readable like that to you as a human, to very quick programming, and can generally enable a lot of powerful and fast grouping, for example, is something that's very fast in pandas, or reorganization of the data, rolling calculations, things like this are generally made faster in certain circumstances by pandas.
It can also be helpful for data cleaning. So that's a really really useful kind of part of pandas. I know we weren't able to touch on that today, but at least within like my own workflow quite a bit, it can be useful for sort of looking at like missing values and just dealing with the data cleaning process, especially with tabular data.
And pandas is very comfortably plugged into the statistical Python stack, so the various plotting and calculations around stats in Python,
as well as machine learning too. So a lot of like TensorFlow and Keras and all these other machine learning packages, you basically set up your data as pandas data frames. So this can be really helpful, especially if you're interested in learning more about machine learning and sort of understanding these underlying data structures. So.
We got
there's another question about whether pandas has in-place functions operating on the data in place.
So we provided some links in the notebook, actually, because this is something that's a very important discussion in how Pandas is used. In a lot of the shorthand in Pandas, Pandas tries to preserve references to data frames and series, even if you assign them to new variables, etc. You can change them in place, even if you're not meaning to. You are able to update or change columns of a data frame, values in a series, etc. Generally, you'll find yourself sort of reassigning these to a new data frame, and this is where you might need to take a couple of things we introduced and double check the Pandas documentation for .loc and .iloc, where they suggest you do make a new copy in a lot of contexts. To answer your question, yes, you can. When you're doing that versus when you're creating a new data frame or series might not always be very explicit, or Pandas may overly try to warn you that it's happening. So be sure to check out the documentation about how those things can be modified depending on what you're trying to get done.
Yeah, I know someone asked about creating a CSV from scratch. So actually in this case, we did a little bit of data cleaning and we read in like a text file and saved it to a CSV. So as long as you have a Pandas data frame, or at least like set up a Pandas data frame, you can save it to a CSV. So.
Or you might find yourself making them in Excel or your local text editor, or
right,
getting them from the internet.
Is there an easy way to iterate over all the different kinds of plots for each column?
For tying Pandas functionality into plotting and shortening that workflow and also making it really pretty, I would check out Seaborn. I used it a lot in school, at least. It has a lot of sort of canned, like, give me this plot for everything in my data frame functionality, and it makes things very, it uses good choices in color to communicate information, and it's very nice to work with.
Yeah, it has some great defaults in terms of the plots. So,
but as far as iterating through the plotting functions available to you in Pandas, it is probably easiest to maybe create your own function that picks out which of these you want to.
Yeah, I know that there's a pretty good. We'll have to link to the Unidata example notebook on that one, because there's a really good one sort of going through and iterating and creating those different types of plots.
There was another question in here on are there any max size considerations, and says that they typically run into struct size problems in MATLAB. My understanding is that, like with a lot of Python, there isn't really a max size consideration except based on your hardware limitations.
So I like, is that in terms of like the total size of the data set?
Yeah, I believe data frame max size.
If you're working with really big like CSV files, I would recommend looking into Dask data frame. There's some really powerful stuff there to be able to work with even like terabytes of tabular data, and it can really deal, because one of the limitations of Pandas is really working with like hundreds of thousands, if not millions of rows of data. So that's where I would look into using like Dask data frame, which has a similar API to Pandas, and provides a lot of the same functionality, except it's a little bit more scalable.
And if you have used or will use X-Ray Dask, its scalability and using it particularly on, say, supercomputing. Basically, it's worth learning Dask if you're working with a lot of data.
Right.
Then
and we'll have a Dask tutorial as well.
Mm-hmm.
So I just included a sample notebook from the Unidata Python training site, which includes this Pythonic data analysis, which works with buoy data. So I know that Seth, you had a question about working with all those different types of plots. There's some really great examples in there of really using the native plotting functionality and working with matplotlib and everything. So.
Okay, thank you. Thank you, Max. Thank you, Drew, for a wonderful tutorial on pandas. Very helpful, very useful. I hope everyone learned enough to be able to continue learning. Our next tutorial is on X-ray, and it'll be a two-part tutorial on June 9th and 23rd, the 2nd and 4th Wednesdays of June. And with that, we'll see you then. Bye.
Thanks
Thanks so
everyone.
much. Have a good one.